Okay, so this question is on question 2.5, application of circle properties, right? So basically for this question here, anything goes, right? You can apply. We have learned almost all the properties so far, and we are going to use the properties that we learned. All right. So here, all right. First, we have the ABCD, right? Or line, all lying on the circumference of the circle, right? This I think is really clockwise. Okay, so no, anti-clockwise. Yeah. So then is given that ACB is equals to 70 degree and ADC is equals to 110. We are supposed to find our angle BAC, right, which is over here, right, and describe the nature of the triangle ABC, right? So here what we do is, okay, there are actually a few methods to go about doing this. One of the methods which I will actually verbally just explain to you first before I write out the steps is that I can first I can observe that, by looking at angles in opposite segments, right, this is 110 and therefore this one will be 70 degrees, right, because of angles in the cyclic quad or angles in opposite segment, right? So with that, right, if I know that this is 70, then by looking at this triangle, right, you can see that this will therefore have to be 40 degrees because they must add up to 180 degrees, right? They must add up to be equals to 180 degrees, right? So that is one idea. Some students may also do this, that if they know that this is 70 degrees, right, then by using angles in the same segment, because they saw a butterfly, they know that this is 70 degree. Now because this is 70 degree, they will know that this is 40, right, because 110 minus 70 is 40. After which, if this is 40, then by looking at these angles in the same segment again, because they know just now that this is 40 degree, therefore this will also be 40 degree. Okay, again by looking at angles in the same segment, right? So there are many methods. So what I'm just said now, I'm just going to write it out. Okay, so first, let me talk about the first method that I chose, which is to look at angles in opposite segments. So angle ABC is equals to 180 minus 110, which is equals to 70 degrees. And the reason I chose is that it's an angles in the opposite segment, right? Angles in opposite segment. So I'm just going to label it on the diagram here. This is 70 degrees, right? So then what about what about BAC? So now I choose to look at this triangle here, right? So we really can choose, you can use a lot of highlighters for your working. You can use all different color highlighters to help you to see the triangles or the segments or the butterflies or the quadrilaterals that you need, right? So next we are supposed to find angle BAC, right? So I just recognize by looking at the blue triangle, angle BAC will just be 180 minus angle 180 minus ABC minus BCA, which is equals to 180 minus 70 equals to 40 degrees. Okay, and this reason here will basically be angle sum of the triangle. Okay, angle sum in the triangle. So with that, we are done. And just by looking at this triangle, you can see that the nature of a triangle ABC, given that how these two angles are the same, well, basically triangle ABC is none other than an isosceles triangle. Okay, it is an isosceles triangle. Okay, so with that, we are done for this question. Okay, hope you enjoyed the video. Thank you.